Welcome to this video. This is a part of assignment. Mm. And in this video, I want to talk about the elasticity of substitution. And in broadly, we will learn or we will see the elasticity of substitution for a linear production function, a fixed production or fixed proportion or Leontief production function, Cobb-Douglas production function, and lastly the CES production function. Okay, what the elasticity of substitution is? This is the first question. The elasticity of substitution, this is expressed by sigma. Uh, this measure the responsiveness of the input ratio K by L. That means, in other words, we can say the sigma or elasticity of substitution means the hardness or easiness to change this ratio. That means how much capital or how much lever we will need or we will take for our production function. For example, the cost of capital fall, and we will take more to this production function, and how much capital we will take. This is said by the sigma. Okay, and there is some intuition for elasticity of substitution. A high sigma means, or high elasticity of substitution means, firm can easily substitute between inputs, and in this case the isoquant will be very flat. Uh, in other words, when sigma is very high, then one producer can substitute input to each other very easily, and when sigma is low, then the producer have in difficulties to changing the ratio. And if the sigma is 0, what is the meaning? That means there is no substitution possible. This is perfectly complementary situation. And when sigma is infinity, that means the ratio or the lever and capital is perfectly substitutable. That means we can substitute all of the capital by lever and all of lever by capital. Okay, and how we can determine the elasticity of substitution? Mm, Firstly, and in general, we can determine the elasticity of substitution sigma percentage change in capital level ratio divided by percentage change in wage and rent. Wage means the cost of labor, and rent means the cost of capital. And this formula, that means percentage change in capital level ratio and divided by percentage change in wage rate, we can express in the derivative form. That means differentiation of capital level ratio and MRTS. Okay, now we are going to learn to determine sigma for linear production function. And as we know, the linear production function, Q equal to A L plus BK, or alpha L plus beta K. That is the general form. And as we know, alpha and beta uh, both are much more, both are greater than 0. Mm, and linear production function mm, provide uh, a quantity which is proportional to L. That means fixed amount increases or decreases in this production function. If we plot the linear production function of graph, and these are the isoquant, and these are very flat or straight line, just straight line, because this is the linear production function, and each isoquant uh, contain the same as in every point. That means q1 is the same production in along all possible point, and q2, and in q2 all possible point represent the same amount as it is known to all. Okay, now we want to learn about the sigma. That means what is the elasticity of substitution of this function or of this curve. Mm, Here, the isoquant is a straight line, and the slope is b minus b divided by a. That means the slope is constant, and when we can take change, that will be zero. That means the percentage change of mrts will be zero, because there is no change, and minus b by a is a constant. That means uh, the elasticity of substitution will be infinity. What is the meaning of infinity? It means that we can substitute perfectly for each other. For example, we can take that amount of L, and where the K is 0 and the production is Q2. And if we take that amount of K, we can produce Q3 production where L equals to 0. That means we can easily or completely substitute for each other. That is the sigma means or sigma indicates. Okay, now for fixed proportion or Leontief production function. As we know, the Leontief production function is minimum uh, AL by PK. This is general form, and why we use minimum? That means when the production is complement to each other, then that's why we use uh, minimum, or Leontief production function contain minimum. For example, mm, a car which need one chassis and four wheels, but we have five chassis and 16 wheels. mm, and what will be the output? We can produce four cars, because four wheels, that means four wheels needed for one car, and there are 16 wheels, that means we produce four cars. But in this, one chases uh, will be remain, or one chases uh, will be unused, because this is the scenario where input are perfectly complement. Okay. In We can take a graph, take help from a graph to illustrate the fixed proportion production function. That means in the q1 isoquant, we can use that amount of L and that amount of K to produce q1. But are we going to that type of production? Obviously not, because if we can produce using that amount of L, why we use that amount of L? It is irrational. That means when we use the maximum or more input, this is just unrealistic, or this is just unused or waste. That means the king point, every king point is the possible output point, and for where we can use that amount of k and that amount of l, and for the every q, that means one input more is just waste of it, nothing else. And in this case, how we can determine the elasticity of substitution. Suppose the function q equal to min ak bl, where ab both are greater than 0. As we see in the graph, their input, but this input not substitutable, or no substitution between k and l. The firm always operate along a ray where kl is constant. Mm, in this for based on this reason, k by l is constant, b by l, that means sigma might be 0 because the mrts is infinity. Let's again take a look. In this point, the king point, we can draw many of lines which represent slope. That means the slope is undefined or infinity. When the slope is infinity, then the marginal elasticity of substitution will be 0. Now take a look for next the Cobb-Douglas production function. And as we are known, we know that the Cobb-Douglas production function is that, and where is the representative of efficiency for this technology, and small a or alpha represent the proportion of k, and b represent the proportion of l in the production function. Okay, and a plus v equal 1, which means or indicate the constant return to scale. And if the ratio or the summation greater than 1, that means increasing return to scale, and for less than 1, that means decreasing return to scale. Now if we want to know about what the a and b indicate, as we know, this is the proportion of k, which amount is used in this production function. But in mathematically we can derive k by differentiating this function. That means ln partial derivative of ln q respect to k. This is actually the representation of a. And when we differentiate this respect to l, this is the simply express the b. Okay, now the mrts will be the mpl divided by mpk, and this is will be like that. For example, as we see that the production function is that, and if we differentiate k and l both separately, then we can find it. In this case, the q is differentiated by l, and where and here the q is differentiated by k, and simply cut down, and just the result is here. This is the result. And taking ln in both side, and into will be plus in natural log. Okay, this function we can write for k by l, this just side is changed, that means that is move toward that, and this is the part will go there, nothing else. Therefore the elasticity of substitution k and between k and l will be 1, because if we differentiate this function respect to this, then the result will be 1. Now let's learn about the elasticity of substitution for CS production function. CS production function means constant elasticity of substitution production function, and general form of the CS production function is like that, where A is the efficiency parameter and alpha is distribution parameter. That means how much capital or how much labor we use in this production function. And rho is the substitution parameter. And gamma the return to scale. That means if we the gamma equals to 0, that means constant return to scale, and gamma greater than 1, that means increasing return to scale, or less than 1, that is decreasing return to scale. Alternatively, we can represent the CS production function like that. We cannot talk about this. We now we can mm, take MRTS by MPL divided by MPK from this function. General form, we can differentiate each other, and with cutting down uh, that, and that will be cancelled out, and only this is remaining. That means L by K P minus 1 to the power P minus 1, and if we take minus and just change the numerator denominator, and 1 minus rho. And we take ln in both side the MRTS and ln k by l, just, and this is solving for k. This is just change, this is change, just change the position, left hand side to right hand side, like that. Therefore the elasticity of substitution between k and l will be that 1 divided by 1 minus rho. This is the elasticity of substitution for CS production function. Here is an example for German industries: food 0.06, iron 0.50. That means in this industry, how much we can substitute labor and capital. We cannot substitute labor and capital in motor vehicle, because the sigma is higher than that. Okay, as we have learned that the sigma indicate the difficulty or easiness, how we can substitute labor and capital for each other, nothing else. Okay, thank you everyone.